Hello everybody, welcome back to OR1. So on this video we will discuss the economic interpretation of dual variables. So in order to explain the economic interpretation of the dual variables, I will use example number 6. So on this example, there is a forester who has 100 acres of hardwood timber, and she has two options. Option number one, she can fell the hardwood and letting the area regenerate, and that will cost $10 per acre, and it will bring a return of $50 per acre. So this alternative will give her a profit of $40. Alternative number two, she can fell the hardwood and plant the area with pine, and that will cost $50 per acre, and the return is $120 per acre. So the profit from option number 2 is $70 per acre. However, the more profitable second treatment, which is the option number 2, cannot be applied to the entire area because she only has $4,000. So the first thing that we need to do is to model this problem into a linear programming model. So this is the model of the problem. So we have two decision variables, x1 and x2. x1 is the size of the area that she will let regenerate, and x2 is the size of the area that she will plant with pine. So the total area is 100 acre. So x1 plus x2 must be less than or equal 100. And then the total amount of money that she has is $4,000. So this is the cost per acre for alternative number 1, which is 10, and 50 is the cost for alternative number 2. So 10x1 plus 50x2 must be less than or equal to 4,000. And the profit from option number 1 is $40, and the profit from option number 2 is $70. So the objective function is 40x1 plus 70x2, and then x1 and x2 must be 0 or positive. So this is the linear programming formulation of the problem, and we call this formulation as the primal LP. And if you find the dual of the LP, so it will give you the problem that I show you in the presentation. Now the next thing that we need to do is we will solve the primal by using the simplex method. So in order to do that, we need to add a slack variables. So we will have two slack variables, x3 and x4. So if you set up the table correctly and you do the calculation correctly, then this is what you will get. So we will have three tables. This is table number 1, which is the initial table, table number 2, and table number 3. And table number 3 give you the optimal solution. So table number 3 is the optimal table. Now the first thing that I want to show you is how to identify the dual optimal solution from the optimal table. Now from this table, it is clear that x1 star equal 25 and x2 star equal 75 and z star equal 6,250. Okay, so those are the primal optimal solution. Okay, now the thing that we need to do now is to identify the dual optimal solution. So the dual optimal solution, so it will be W1 star and W2 star. So the location of W in the optimal simplex table is right below, no, I mean it is in the Z row below the slack variable. So this is our 0 and those are our slack variable. So it is in the 0 right below the slack variable. So those are our optimal dual variables. So since it is a maximization problem, so the coefficient of z is -1, so we'll have the value of W1 star is minus of the value, so which is 32.5. So we just take the -1 times minus 32.5, and then W star is -1 times -3/4. Okay. So that is the so this is the optimal, the dual optimal solution. Okay. Okay. What is the value of z star of the dual? As I explained previously, that when the dual is optimal, then when the primal is optimal, then the dual is also optimal, and the value of the z star is the same. So value of z star for the dual should be the same as the value of the z star for the primal, which is 6,250. The other thing that we need to identify, and we're gonna use this in interpreting the dual variable. That is what we call as the B inverse. So B minus 1. This is the B inverse. So it is a matrix. Okay. So the B inverse is in the constraint row. So we have two rows for the constraint here in the table. So one for the x1 and the next one is for the x2. So the location of the B inverse, it is in the constraint rows right below the slack variable. So this is the B inverse matrix. So what is your B inverse? So the B inverse is 1.25 minus 1/4 minus 1/40 and 1/40. Okay, so that is the B inverse. Now my objective is to explain what is the economic interpretation of W1 star and the W2 star. In order to explain that, I will come back to the problem. Now, suppose that after having the optimal solution, the forester, she has two more options. Option number 1, she can borrow $100 now and pay back 180 later on. Option number 2, she can invest the money, which is the $4,000, and when she invests 100 now, and she can collect $180 later on. So here, after getting the optimal solution, she has two options. Option 1, borrow money. Okay, so in that case, borrow 1,000, borrow 100, pay 180. So that means 80% interest. Then option number 2, invest money. So invest 100, collect 180. So the return on investment equal 80%. Now the question is that which option that she should select. Okay. So in order to decide, should she select option number 1 or should she select option number 2? So the dual variable will help us in order to decide that. So we will use this equation in order to determine whether the forester should select option number 1 or option number 2. We will use this equation, the equation in the middle, z star hat equals z star plus w star times t. So the z star hat is the new value of the z star after doing something with the money, borrowing or investing the money. Now the t over here, it is the amount of money that you will invest or the amount of money that you will borrow. So since we have in this problem we have two constraints. We have constraint number 1 and constraint number 2. So here is our constraint number 1 and here is our constraint number 2. But the thing that we will do here, it is only for constraint number 2, because we will decide whether we will add money to the 4,000, meaning that we borrow money, or we take some money from the 4,000 and we invest that money. We will do nothing for constraint number 1. So here t is how much that you will increase or decrease your right hand side. So in this problem we will have t1 and t2. t1 is the increase or decrease that we will apply for constraint number 1, and t2 is the increase or decrease that we will do for constraint number 2. So since we will do nothing for constraint number 1, so t1 equals 0 and t2 is not 0. Okay. Now assume that for the forester for option number 1, C decide to borrow $1,000. So that means that C needs to pay $1,800 later, or $800 is the interest. Okay. Now if she decide to borrow $1,000, what will happen to the new value of the Z star? So we will do the calculation. So Z star new will be the current value of Z star, which is 6,250, plus W star. So we know the value of W star, which is let me see, 32.5 and 3/4, so 32.5 and then 3/4. And then times T1 and T2. Okay, so that will be a matrix. So times T1 and then times T2. Okay, with T1 equals 0 and T2 equal, because for option number 1 she borrow money, so she will get money, so that's a positive cash flow, because she get the money from the bank, so that's a positive 1,000. Okay, so this is a matrix. Okay, now if we do the calculation, what we will have over here is, so 6,250 plus 3/4 times T2. Okay, so in this case T2 is equal 1,000, so that will be 6,250 plus 750. So when she decide to borrow money, then the value of the objective function will be increased by 750. However, she needs to pay $800 interest, so that means she is losing money. Why? Because the increase in the objective function value, or it is only 750, but the interest that she need to pay is 800, so she is losing 800 minus 750, which is $50. So if she decide to choose option number 1, she will lose money, and the amount of money that she will lose is $50. That's option number 1. What about option number 2? For option number 2, assume that she invests $1,000, so the return that she can collect will be, so the return on the investment will be 1,800, or the return is $800. So means is C can collect. Okay, here C can collect $1,800, meaning that the return is $800. So we can use the same equation. We can calculate the Z star new, for option number 1. So that will be 6250. So we will use this equation plus 3/4 times T2. Now what is the value of T2 over here? The value of T2 over here, it should be minus 1,000. Why it is minus 1,000? Because she invests money, so she is taking $1,000 from the $4,000. So that means the money flowing out. So that's why it has a negative value, minus 1,000. So so this equal to 6,250 minus 750. Okay, so that means by choosing option number 2, the value of the objective function will decrease by 750. However, from the investment, the return is $800. So if she choose option number 2, she is getting money. How much money that she will get? So it will be $800 from the return on the investment minus 750, the reduction in the in the value of Z star. So she is getting money $50. So it is very clear that option number 1, option number 2 is better than option 1. So she must select option number 2. So before I continue, I think for option number 1, the value of T2 over here, it is positive 1,000. So I already put that thing on this matrix. So I just want to make it clear so you guys will not confuse. Now I am coming back to the objective of this video, which is I want to explain what is the meaning of the dual variable. Remember, the value of W2 star is 3/4. So what does that mean? After having this example or this illustration, so the meaning of W2 star 3/4 means that for every $1 increase in the value of right hand side number 2. Remember, we have two right hand side because we have two constraints. So the right hand side number 2 is the $4,000. So when you increase that value by $1, then the value of Z star will increase by $3/4. And by using the same logic, for every $1 decrease in the value of the right hand side number 2, so the value of Z star will decrease by 3/4. Now what is the meaning of W1 star equal 32.5. So that's mean by for every 1 acre. Why it is acre? Because remember, the first constraint, it is for the area of the land. For every 1 acre increase in the area of the land, the value of Z star will increase by 32.5 dollar. Okay, so that's the economic interpretation of the dual variable. Now let's assume that the forester choose option number 2. So she decide to invest $1,000. Now by investing $1,000, that means that now your right hand side, it is not 4,000 anymore. You are taking $1,000 from the $4,000. That means it is not $4,000 anymore. Now it is $3,000. So now if it is $3,000, will your x1 star equal 25 and x2 star equal 75? It will change. It will not be 25 and 75 anymore. So now what is the new value of the x1 star and x2 star? So in order to calculate the new value of the x1 star and x2 star, we use this last equation. So the new value of x star equal the current value of x star plus b inverse time t. So for this problem, the value of x star consists of x1 star and x2 star equal, that's equal 25, the current value of x1 star, and 75, the current value of x2 star, plus the B inverse. What is your B inverse? So we know that the B inverse is here. So 1.25 minus 1/40 and so on and so forth. So that will be 1.25 minus 1/40 and then minus 1/4 and then 1/40 times t, which is times t1 and t2. Remember, your t1 is 0 and your t2 is minus 1,000 because you invest $1,000. So this is a matrix operation. So this is a matrix. This is a matrix, and it is also a matrix. Now, what is the value of x star? So the value of new x star is that will be, if we do the calculation correctly, that will be 50 and 50. So when the forester choose option number 2, then the new value of the x star will be 50 for the x1 star and 50 is the value of the new x2 star. So I think that is it for the economic interpretation of the dual variable. Thank you very much.